Hello students, welcome to episode 16 of Decode NCERT, where today we are going to decode the chapter Aldehydes, Ketones and Carboxylic Acid. Now before proceeding, as I tell you every time, what is the purpose of this class? So in this class I am not going to teach you anything about aldehydes, ketones and carboxylic acid. For that we have already made many videos, but yes, now after everything, reading every concept and everything, still we are left with that we haven't read the NCERT line by line and what to what, right? And it really takes more time here. So to help you with this, I will go through the whole chapter and I'll tell you that which are the most important things that you have to prepare, okay, which you have to read from the NCERT book. Like what all questions can be asked from this particular section, I'll be telling you. You need to highlight those important things and you need to focus on those important things while studying the NCERT book, right? So now you have to sit with the notebook, with your NCERT book, a highlighter, a blue pen and a black pen or a pencil to write down the questions, okay. So now let us get quickly started. So this will be hardly be like 15-20 minutes where we will be just overlooking the chapter, okay. So here, like if you see the previous chapter, alcohols, phenols and ethers, in this intro part also some important things were there, okay. But in this chapter there is nothing much given, you do not have to read this, but yes, you can go through these structures once, okay. After that you can just skip it, and here there is small uses that is given about the, I can say about the how it is used as a fragment, okay. Aldehydes, ketones and carboxylic acid have good fragments, how that is used, here something is given regarding that, you can just highlight this one, okay. Next, coming to the common structures here, these are very important. So yes, 1 second students, yes. So this vanillin, okay, vanillin, salicylic aldehyde and cinnamon aldehyde, okay. So these three structures and their name you should be knowing, okay. Now moving forward we have okay, yes, now we'll come to nomenclature. So nomenclature is what you have to follow the general rules, there is nothing extra which you should not be knowing, yes, but common name you have to prepare again, okay. Similarly here we have common names of the ketone group, okay, how the common name should be done. So please prepare these common names, okay, because common names are also equally, I can say, popular in aldehydes and ketones. Next, coming to this one where we have, these are all aldehydes and ketones, so these are just normal nomenclature, do not have to worry much, okay. Now here I will be telling you certain things that you should remember, okay. Common name are again very important: acrolein, varaldehyde, phthaldehyde, alpha methoxypropion aldehyde, then gamma methyl cyclohexane carbaldehyde, isobutyl aldehyde, okay. Then next you have these are common name, not very complicated. This is again something you should be knowing, macetyl oxide, okay. All the common name, the table you should be learning properly, okay. Now coming to the structure of the carbonyl compound, okay. So under structure you should be first knowing that it is carbon is sp2 hybridized, bond angle is 120 degree, trigonal planar structure, okay. Next, this diagram is important, you just be knowing about the structure of this one. Now coming to, this is nothing important here. Next we have preparation of both aldehydes and ketones. So this is the generally you will be studying even if you do not study NCERT book. These are the things that you have to study, right? Oxidation of alcohols, dehydrogenation of alcohols from hydrocarbons by ozonolysis of alkenes. Then you have by hydration of alkynes. Next, coming to preparation of aldehydes from acyl chloride, the Rosenmond reaction, the statement and the reaction. Next, from nitriles and esters you have Stephan reaction, and you have one more thing, that is dibyl H reagent, okay. Next, from hydrocarbon, that is by oxidation of methyl benzene, okay. So use of chromyl chloride, and next you have your, that is your Itard reaction and use of chromic oxide, okay. Next we have here side chain chlorination, this mechanism is there, and here you have to important that this is a commercial method of preparation of benzaldehyde. So if the question is asked, mention the commercial method of preparation of benzaldehyde, then you have to write only this particular mechanism. So that is the importance of this particular method, okay. Next, Gattermann-Koch reaction, again a name reaction, you should be knowing here. Next we have acyl chlorides, preparation of ketones from acyl chloride, so dialkyl cadmium, that is the first method. From nitriles, okay, these are the things that you should be knowing, okay, there is nothing extra, means even if you do not study this part from your NCERT book, that is fine, because your class notes and everywhere you must have studied about the preparation methods, okay. Next, from benzene sulfonic acid, okay, so here the Friedel-Crafts acylation reaction is there, this we all know. Then you can practice these questions, okay, please do all the in-text questions of organic chemistry, very very important. Now we will move towards the physical properties, okay. So methanol is a gas at room temperature, ethanol is a volatile liquid, so this is not very important. Here it is important, the boiling points of aldehydes and ketones are higher than the hydrocarbons and ethers. What is the reason? It is due to the weak molecular association in aldehydes and ketones arising due to the dipole-dipole interaction, okay. The point is dipole-dipole interaction. The next one is the contrary statement, their boiling points are lower than those of the alcohols. Why? Because of absence of hydrogen bonding. So the yellow color part can be question and the pink color highlighted part are your answers, okay, from physical properties. Next, if we go here, you can see how the hydrogen bonding is taking place. If diagram is required, you can draw this. Next, we have that solubility, okay. All aldehydes and ketones are fairly soluble in organic solvents like benzene, ether, methanol, chloroform, etc., okay. Next, we have something, okay, here also important point is there which you can highlight. Lower aldehydes have a pungent odor, okay. As the size of the molecule increases, the odor becomes less pungent and more fragrant, okay. In fact, many naturally occurring aldehydes and ketones are used in the blending of perfumes and flavoring agents, okay. Fine. Now coming to next, this in-text questions, please do it. Okay, next coming to the nucleophilic addition reaction. So mechanism of addition reaction, very very important. You can draw this particular mechanism, okay, this is there, mechanism of addition reaction, this is there. Next, if we have, this is a very potential question and this is also like not a very like question which is not known, it is there in your PU, like in your I can like it is there in your exercise question also, and very common question that why aldehydes are more reactive than ketones. Two reasons are explained here. If you want, you can read from the book and answer this particular question, okay. Next, coming to addition reaction of HCN, mechanism many times is asked, so please prepare this particular mechanism, very very important, okay. This is sorry, yes, one second, this is important mechanisms, okay, clear. Next, if we move the normal addition reaction, addition of NaHSO3, nothing special here. Next we have okay, here something important is there which I missed. Let us see. The position of the equilibrium lies largely towards the right hand side for most aldehydes and to the left hand side for more ketones due to the steric reason. The hydrogen sulfide addition compound is water soluble, this one, okay. The hydrogen sulfide addition compound is water soluble and can be converted back to the original carbonyl compound by treating it with dilute mineral acid or alkali. Therefore, these are useful for separation or and purification of aldehydes. So here we can have a question, okay, so this is important, okay, why this particular reaction can be used for separation and purification of aldehydes. So if there is a mixture of aldehydes and ketones, okay, so ketones will go back but aldehydes will remain in this particular direction, okay, so that is there, aldehydes can be separated in that way, okay. Next, if we move forward, one second, yeah. So next is addition of Grignard reagent, addition of alcohols. There is nothing different here, but yes, something we should be knowing about acetal and hemiacetal, okay. So the proper acetal definition you should be knowing from here, okay. Next we have mechanism done, this is not important. Yes, next addition of ammonia and its derivative, this is super important in this chapter, mechanism is here, and this table is very very important, okay. you should be knowing the reagent's name, okay, and the corresponding product's name. And this Skiff's base, you should be knowing what is a Skiff base, okay, which of the following is a structure of Skiff base. Question can be asked like this, okay. So this table is very important, okay. Next we have reduction, okay. So reduction to alcohols, that is there. Reagents you should remember. Then reductions to hydrocarbon, here we have Wolff-Kissner reduction and Clemmensen reduction, okay. So these all things that are there in your chapter you must have read. Oxidation, so different oxidizing agents are there. So when aldehydes are oxidized we get acids, but yes, when ketones are oxidized there are multiple products formed. So please you can remember this example, okay. Oxidation of ketones, C1 C2 bond will break, what product will form? C2 C3 bond will break, what product will form, okay. After that, if we just move forward, Tollens reagent, then Felling's test. Here something is asked, what is Felling solution A, Felling solution B? Felling solution A is copper sulfate and Felling solution B is an alkaline sodium potassium tartarate, alkaline sodium potassium tartarate, okay. And it gives you reddish brown precipitate, okay. Next we have okay, sorry, one second, okay, fine. Next we have that aldehydes are oxidized to corresponding okay. Now here aromatic aldehydes do not respond to this test. The question was asked why. So the answer is very simple. If you take aromatic aldehydes in presence of this aqueous NaOH and KOH, it gets converted, or it undergoes Cannizzaro reaction. It doesn't go this Felling's reaction, okay. Next is oxidation of methyl ketones. So this is your haloform reaction. This is important, right? These reactions are important. Next, okay, so here is the importance of iodoform reaction. This in text questions, please solve it. Again, this is important. Then coming to your aldol condensation, right? So just you should be knowing aldol condensation mechanism is here, okay. Name, reaction, definition is given. Then here we have aldol condensation, again it is defined. Then cross aldol condensation, what is there, this product. So this particular example you should be knowing for cross aldol condensation, okay. Next if I go Cannizzaro reaction, again the definition and products. So these all things are there by default, you should be studying, okay. Next electrophilic substitution reaction also is there, okay. Next we have this in text questions that you should be solving, okay. Next coming to uses of aldehydes, this is very important from where questions can be asked, okay. So you can see first one, okay, formaldehyde is well known as formalin, okay. Sorry, one second, yeah, formaldehyde known as, let me little bit zoom it, okay, yeah, formaldehyde also known as formalin is used in biological specimens and to prepare bakelite, okay. So this is important. Then it is used to prepare bakelite, urea, formaldehyde glues and other polymer. Next, acetaldehyde is used as a primarily starting material in the manufacture of acetic acid, ethyl acetate, vinyl acetate. So this you can guess, but benzaldehyde is used in perfumery and in dye industries, okay. Then we have certain acetone and ethyl methyl ketone are common industrial solvents. Many aldehydes and ketones, example butyride, vanillin, acetophenol, camphor, etc. are well known for their odors and flavors. But the thing which I found is very important here is this formaldehyde known as formalin, and it is used in the preparation of bakelite, okay. Please remember this one, very important. I'll tell you why at the end of this session. Now coming to carboxylic acid, there is nothing much important in this particular paragraph. Structure of carboxylic acid all of you will be knowing, nomenclature is there, but yes, this is important again, the common name of these carboxylic acid you should be knowing, okay. And now once this is done, we will go to structure of carboxyl group, okay, that is also not very important, okay. Yes, methods of preparation from primary alcohols by direct oxidation. This is by default, like you will be studying, there is nothing important here like which I should be telling. Yes, so here you should be saying that if this side chain is primary or secondary, it will get converted to acid, but if it is tertiary, it won't undergo oxidation. Okay, then from nitriles and amides, from Grignard reagent, how the preparation will take place, from acyl halides and anhydrides. So these all mechanisms or reactions are there, from esters. Okay, then do these conversion questions, important one. Okay, in text all questions, please solve it. Okay, now here also nothing much important or difference I'll tell. Physical properties, we have something regarding the solubility, here something important is there, let me see. Yes, this one is, okay, here this part. Okay, now see, carboxylic acid are higher boiling points than aldehydes and ketones and even alcohols. Okay, this is important. One second, yeah. Now carboxylic acids are higher boiling point liquids than aldehydes, ketones and even alcohols of comparable molecular masses. This is due to the more extensive association of carboxylic acids molecules through intermolecular hydrogen bonding. Okay, the hydrogen bonds are not broken completely even in the vapor phase. In fact, the most carboxylic acid exist as dimer in the vapor phase as in the aprotic solvents. Okay, you can see the hydrogen bonding in carboxylic acid. Okay, next we have okay, here coming to the solubility. Okay, so this is very simple. The solubility decreases with the increase in the number of carbon atoms. Higher carboxylic acid are practically insoluble in water due to the increased hydrophobic interaction of hydrocarbon part. Benzoic acid, the simplest aromatic carboxylic acid, is nearly insoluble in cold water. Okay, so this is about solubility, that is about the boiling point. Okay, after this we'll move towards the chemical properties. So the reactions with metals, that is the acidic nature. These all things you have to study, there is nothing important. Yes, here something is there that can be asked as a question, that is one second, yeah, carboxylic acid are amongst the most acidic organic compound you can have. Now the higher acidity of carboxylic acid as compared to phenol. So the question can be here like this: why carboxylic acid are more acidic than phenols? Okay, so the answer here is given in the next paragraph, this one. Okay, this green highlighted one can be the question. Okay, so the answer for here is the conjugate base of carboxylic acid, a carboxylate ion, is stabilized by two equivalent resonating structures in which the negative charge is at the more electronegative oxygen atom. Now the conjugate base of phenol, a phenoxide ion, has non-equivalent resonating structures in which the negative charge is at the less electronegative carbon. Okay, therefore the resonance in phenoxide ion is not as important as it is in carboxylate ion. So two things, it has equivalent structures and the negative charge is on the more electronegative atom, and here it has non-equivalent structures and the negative charge is on the less electronegative atom. So both the factors here contribute for less stability in case of phenoxide ion, and in carboxylate ion both the factors contribute for higher stability. So that is why carboxylic acids are more acidic than phenols. Okay, next moving forward here, effect of substituents. So we have electron withdrawing group will increase the acidity, donating group will decrease the acidity. Okay, next here order you should be knowing of electron withdrawing group order, that is important. Next I don't find anything important. Yes, reactions are there, formation of anhydride, esterification, these all reactions you have to study. Reactions with PCl5, PCl3, reaction with ammonia. Okay, then you have reductions of reductions of carboxylic acid, decarboxylation, halogenation. Okay, all these reactions you should be knowing. Ring substitution. Okay, yes, this is the most important part in this chapter, I can say, from where MCQs can be asked. First of all, methanoic acid is used in rubber, textile, dyeing, leather and industries and electroplating industries. Ethanoic acid is used as a solvent in vinegar and in food industries. Now you might be thinking that Ma'am is telling just like this is important, but yes, trust me, in the midterm paper, in midterm paper, there was question that hexane which of the following is used in the manufacture of nylon 6,6. This question was there in some of the recent midterm paper. So you can see that questions are asked from different corners of the book. So we cannot neglect anything, right? So that is why this is again a very, very important statement. Next you have, so this time it was asked for hexane dioic acid, it can be asked for formalin, which was used in bakelite. So now see, methanoic acid is used in so many things, right? It is not anything specific, but here you see this is very specific, that in nylon 6X this is used. Similarly for formaldehyde, we see that it is very specific and used in the preparation of bakelite, right? Similarly, you have here sodium benzoate is used as food preservative. Next, higher fatty acids are used in the manufacture of soaps and detergents. This is not that important, but yes, this methanoic acid and hexane dioic acid and sodium benzoate are very important. Okay. So yes students, that's all in this class. So quickly I have discussed. So what I'll say is, in this chapter, okay, there is not many thing that is there from the inside of the book, the general overall reactions, okay, and the preparation method, and this chapter has the highest number of name reactions as well, okay. So if you want to do this chapter, do the name reactions, okay, complete the name reactions first and then do the like acidic order. So if I want to tell you the must do topics from this chapter is your name reactions, acidity order, and why aldehydes are more reactive than ketones. These three questions, and that why carboxylic acids are more acidic than phenols. These 4 questions you have to do. And but name reactions, there are almost I think 13 or 14 name reactions from this particular chapter, so do not miss it, okay. So that's all students in this class. Thank you for watching and see you soon in the next episode.